All right, so the time is going up in days by 5, up by 5 each time. So the time is going up by the same amount each time, right? The number of flu patients is going up by 6 each time, isn't it? So 53 minus 47 is up 6, and this is up 6, and this is also up 6, exactly every time, right? And so we have a constant growth rate, basically, which is every 5 days we have 6 extra flu patients, all right? Which is constant growth rate. So that is that's why it's linear, okay? We have a constant growth rate, which is basically 6 extra patients every 5 days. And we can do this. We can go take our 6 divide by 5, and that gives us 1.2. So our growth rate is it's 1.2 patients each day. Does that make sense? You know, so that would be, you know, question. So this is question 39. This is why it's linear, right? So question 40, what's the slope? Well, the slope is basically the rise over the run, or the increase in outputs. You know, it's like the output, the y increase, the output increase over the input increase, let's say, right? Or the rise over the run, or the y's over the x's, difference in the y's or over difference in the x's, and it's 6 over 5. You might remember from algebra, it's kind of like your y2 minus y1 over x2 minus x1. Remember that? So it's like, you know, pick any points there. It's, you know, 47 minus 41 over 10 minus 5. Which gives you 6 over 5. No matter what you do, you're always going to get 6 over 5, right? Does that make sense? So that's the slope, or 1.2. And (41). So a formula, so it's a linear equation, so it looks like this, right? And a formula would just be, well, the slope is 1.2, so 1.2x, right, plus the y-intercept, which is 35, right? Because when x is 0, the y is 35, right? And then you can just use that formula to do number 42, which is what would you expect to be the total number of diagnosed flu cases after 17 days? So question 42 is just asking, well, if x is 17, what's the number of flu cases we expect, right? So you just plug 17 into the formula. You just go 1.2 times 17 plus 35. And then that's the answer, whatever that is. Right, so it's just 1.2 times 17 plus 35. Right. So about 55 flu patients on day 17, right? So like on day 15 there was 53, day 20 there was 59, so 55 sounds about right for day 17. It's in between there, isn't it? So, yeah, that's all. I mean, if you were to, like, ooh. Graph that. Let's see. To graph that, you know, this is what it looks like. Here's day 0, 35 cases, right? Day 5, you've got 41. Oh, 541. See that? Oops. Well, I guess I could probably type that in. I think I can do that. 5, 41 is there, right? So 10 days we had 10, 47, right? And 15 days we had 15, 53, right? And then, and so my point is these points are on, see how these points are on a straight line, right? You see that?
Yes.
Yeah, just show that, you know, a linear function is a straight line. And it's always of the form y equals mx plus b, the slope times the input plus the y-intercept. So we start at 35 cases, day 0, right? And we go up by 1.2 cases every day. And all those points are in a straight line. That's a linear function. It's a straight line graph, right? So that's another way to show it. If you wanted to show it as a straight line graph, you can do that as well. Or you could just make a little graph by hand with that or something, you know?